This tutorial will explain the parameters function in the PROFIS Detection app and how to use different parameters to obtain a correct and meaningful analysis of the radar data. The Parameters button adjusts the numeric processing of the data, which has a great influence on the visualization and data evaluation. Changing one of these settings automatically triggers reprocessing of the whole dataset. Depth scaling is one of the most important settings for radar data analysis and can be adjusted here. The concrete parameter is the permittivity or dielectric constant of the base material and adjusts the depth scaling of the embedded object, structure, or layer thickness. To obtain correct depth indication, it's important that this numerical value correspond to the physical characteristics of the scanned material. The general rule for permittivity value is that the drier the base material is, the lower the value should be. Typical permittivity values for scanned material are listed in the table. The appearance of certain artifacts in the cross-section view may indicate that the setting is incorrect. The object reflections are only shown as nearly perfect circles in the cross-section view when the parameter for the concrete value is correct. Another way to find the right concrete value is to calibrate the depth based on a known thickness, for instance, the slab thickness. The focus offset parameter is used for improving data visualization by correcting the position of the focus length to generate a sharper image. Its default setting should only be changed for very heterogeneous materials, layered structures, or if an overlay is used. The overlay function is important when scanning an uneven surface or expanding the scan surface. Check this box to activate the overlay function. The thickness value indicates the actual overlay thickness in the selected unit of measurement. The value for concrete is used to indicate the relative permittivity of the overlay material. Typical permittivity values for overlay materials are listed in the table. The processing section allows you to further customize your visualization. The filter type is used to clearly show objects at close range. The default median filter is, generally speaking, the most accurate method. The selective filter is best suited for specific configurations like bars forming a close, tightly spaced grid. The high-pass filter is used for long, quick-scan recordings of heterogeneous material or detecting objects embedded more deeply. The method parameter is used to amplify the signal and provides two options, each applying different gain factors. The standard method is for objects at shallow to moderate depth, whereas the advanced method is for objects lying in several layers. The focus type feature can be used to improve data visualization. The fast setting is used for homogeneous scan material, whereas the advanced setting can be used when scan material is heterogeneous. The data parameter allows a selection to be displayed in the cross-section image. There are 5 steps within the processing chain, moving from raw data to default data. If the user wants to locate objects, the default setting should be used. To find the slab thickness or the layer thickness, switch the setting to raw data. The Z summation influences the visualization of the top view. Either the maximum or a smoothed image over the average of the slice thickness is shown. Parameters we covered in this section are used to optimize the data evaluation, but keep in mind that each scan and scan location is unique and may require a unique set of parameters. We recommend trying each of these options to find the best fit for your analyzed scan.